How large are large language models? So this person basically tried to be as factual as possible about the size of large language models. They had to clarify none of this document was written by AI. I do not include any information from leaks or rumors. It's on the base models, the raw text continuation engines, not helpful chatbot assistants. This is a view from a few years ago to today of one very tiny fraction of the larger LLM story that's happening. So here's what's happening. Well, here's the history, rather. We had Geppetto 2, medium, large, and extra large in 2019, and their respective sizes in terms of token sizes. It's said that it was 40 gigabytes of internet text. Geppetto 3, well, they don't have an exact size here, but you can almost infer the size by simply doing the math between 1.61 billion with a 40 gigabyte set of training data to 175 billion parameters. By the way, these parameters are, just to generalize it a bit, it's like how many points does the AI system have to like be tweak to get the right output. It's a massive generalization, but that's the more parameters it has, the better it's going to give you output, or so they say. So you can kind of infer the size. And then Geppetto 3.5 and 4, there's no factual information. Llama had 1.4 trillion tokens. That was some of the earlier versions. And now it's almost doubled, I believe, 3.67 trillion in total. That's quite a bit. There's some kind of a new trend, which annealing, I guess, is like, well, you know what? Instead of me trying to remember this from memory, let's just look it up. What is annealing? It's approximating a global optimum of a given function. So another way to put it that I've read this is that if you anneal data, it can also mean that you kind of necessarily have the LLM forget stuff so that it has room to generalize stuff that it already went through, so that it's more optimized about going through this stuff. I don't truly, frankly, I'm not an expert in that, so I might be getting this wrong. But anyways, I guess that's what's happening here. Calling out that the fact that they're doing this means that the number of tokens that exist can kind of like adjust because of the methods that they're using here to adjust, like optimize the training data and the outputs, and put all that together, and it kind of gets wonky. The DeepSeek stuff. Yes, there was a dramatic increase in size with DeepSeek. I don't know if they actually go over the increase in size. Yeah, here we go. So they have they definitely had a huge uptick on the DeepSeek V3 versus V2. You can see a huge I think it was like more than twice, if I remember correctly, in terms of tokens and stuff, which means that the size of the model itself is like pretty large. It would have to be. And then it continues covering this. I thought it was a really good article about like this size and scope of these things. So part of the article, well, I guess this, whatever this document is, they actually plotted the size increase. And this I thought was interesting. I thought it would include this because I have a feeling that I might refer to this later on. But you can see an exponential growth in the parameter sizing of these models going from 2019 to 2025. And I think one of the reasons that I wanted to cover this and get it on record is that as time carries on, there's going to be something to say about the exponential growth size of these models and their tokens and the quality of output we get. And I think there's going to be an ability to compare the output to the size that the size increase of these models and say what the hell's going on here. So I wanted to get this on record. I wanted to cover it and have this reference. I thought this was really good. It was kind of one that I stumbled across. It's not easy to find this one, but yeah, there you go. It's covered now.